Welcome to another unit of the ISM Exercise Set Statistics 2, this time with a unit on the hypergeometric distribution. Let's have a closer look at the exercise. 3 types of t-shirts are produced at 2 locations. For the different type of t-shirts, the following rejection rates result. Now we have here an overview for the 2 locations. And we have an additional information. At location 1, a quality check is conducted. In the first step, a charge of 100 large shirts is selected. From the 100 shirts, in a second step, 3 shirts are selected at random for a more in-depth analysis. Our tasks now: A. What is the probability that all 3 shirts are rejects? B. What is the probability that of the 3 shirts at least 1 is a reject? Let's start with the first one. Here we want to have that exactly 3 are rejects. So we consider first off our population size, that's here 100. Then we have the rejection rate, meaning we can multiply the rejection rate with the 100, giving us here the 28 we can suspect to be rejects. And we have our sample of 3 shirts. And we also know this is going to be the hypergeometrical distribution, because once I pull 1 shirt from the population, I won't be pulling the same one again, and also the probability will change. So when I pull 1 shirt and this is a reject, I will only have 27 rejects anymore in the 99 total. So the overall probability of getting another reject will be changed. This is an indicator for us having a hypergeometric distribution. Okay, so we know we need the probability function for the hypergeometric distribution. This one we are going to take and enter here the values 28, 103. Then we get 28 over 3. So in the population, we will have 28 rejects, and we want to know what's the probability of having 3 of them in our sample. We will have 72 non-rejects in our sample. There should be 0, so 72 over 0. And in total, we have 100 shirts, and our sample size is 3, so we divide by 100 over 3. This then results in a probability of 2.03%, so there's a roughly 2% chance that all 3 of our shirts, which we selected randomly, will be rejects. So much for part A. In part B, we want to have the probability that we have 1 or more shirts. 1 or more shirts? Well, I could go and calculate the probability of having 1 shirt, 2 shirts, 3 shirts being rejects, or I just consider the counter probability and go with 100% minus there's no reject, because that's the only opportunity which we are left with. Okay, this also makes sense because then I don't have to calculate 3 probabilities but only 1. Okay, the same numbers we had in A also apply here. So our K, the number of shirts which are rejects, are still 28. We still have an overall charge of 100, and we take a sample of 3. So we enter these numbers into the probability function of the hypergeometrical distribution, giving us here values as follows. So it's 1 minus, then 28 over 0. So of the 28 rejects, we want to have 0 in our sample, but of the 72 non-rejects, we want to have 3 in our sample. And all of this is divided by 100 over 3, so we take a sample of 3 out of the 100 t-shirts. We put this into our calculators, giving us an overall result of 63.12. So the chance to having at least 1 shirt which is defective in our sample is roughly 63%. Well, this then already concludes this exercise. I hope you enjoyed listening to it. And if you want to see more exercises, feel free to visit the rest of the exercise set or take a look in the corresponding playlist. I say goodbye and see you next time.